Assalamu alaikum. Hello, grade 12. Today we will discuss alkene. The first member of alkene is methane. The first member, you know that alkanes general formula CnH2n+2. What's meant by alkene? Alkanes are aliphatic hydrocarbons. As we know, alkene are found in large quantities. We can find them in crude oil أو في البترول يعني. In crude oil. They are separated by fractional distillation. What's meant by fractional distillation? In our syllabus, we have two types of distillation, fractional and fractional distillation and normal distillation. Fractional distillation means what? If you have two miscible liquids or two liquids which are mixed together, we can separate them by using the boiling point. For example, if we have water and alcohol, you know that alcohol boils at 78 degrees centigrade and water boils at 100 degrees. So if we want to separate water from alcohol, we start to boil the mixture. The first substance which will evaporate is alcohol, then water. Alcohol will be vaporized at 78 degrees while water at 100 degrees. This is called fractional distillation. So alkene are found in large quantities in crude oil and they can be separated by fractional distillation because the crude oil contains many liquids which are mixed together. Okay. Methane, which is the first alkene, is the simplest organic compound on Earth. Methane represents what? More than 90% of natural gas, بلاقيه في الغاز الطبيعي بنسبة 90%, that's present in deep in earth, accompanying the crude petroleum. يبقى احنا بنلاقيه في مكانين، يا إما مع البتروليوم بنقدر نستخلصه من البتروليوم، أو we can take it sometimes we can find it on the surface of the crude petroleum oil. It is also found in coal mines, which are prone to explosion as a result of burning. في المناجم بتاعت الفحم بيبقى فيه الميثين وأحيانا بيسبب انفجار لأن هو flammable. Methane is called the gas of swamps. Why? Because it's found as bubbles. Due to decay of organic matter, this gas will evolve and found above the organic matter. Now, what's meant by preparation of methane? We prepare methane by a method which is called dry distillation. As I said before, we have two types of distillation. The first one, which is fractional distillation. The second one, which is dry distillation. What's dry distillation? We take anhydrous sodium acetate. This is the formula of sodium acetate, CH3COONA. And we put soda lime. Soda lime consists of two compounds, sodium hydroxide and calcium oxide. What will happen after heating? We can find that CH3COO will take H from NaOH. CH3, this compound, CH3COONA, this part will be separated, COONA with NaO. So we have Na2CO3, sodium carbonate, and the H, this H will be added to CH3, so we get CH4. So we can say that the preparation of methane in lab takes place by dry distillation, and dry distillation means heating anhydrous sodium acetate with soda lime. We get anhydrous sodium acetate by the reaction of sodium with acetic acid. The mixture of soda lime consists of two substances, sodium hydroxide and calcium oxide. Sodium hydroxide is called caustic soda. Calcium oxide is called quicklime. Okay. The gas which will be produced can't dissolve in water, and it is lighter than water, so it evolves in the tube. Again, if we prepare methane in lab, we can prepare it by using dry distillation, which means heating anhydrous sodium acetate with soda lime, and soda lime consists of mixture of caustic soda and quicklime. By using this apparatus, we can get CH4 by heating, okay? If I ask you, using soda lime instead of caustic soda on preparing methane gas in the lab, why we use soda lime instead of caustic soda only? Because calcium oxide, which is present in soda lime with sodium hydroxide, reduces the melting point of the reaction mixture. يبقى أنا بحط ال CaO عشان أقلل الميلتنج بوينت بتاعت الميكشر، لما أجي يسيح بسرعة أو يسخن بسرعة فيطلع البرودكت أسرع. Okay. The general properties of alkanes discuss each of the following. First, we can discuss the physical properties of alkanes, then the chemical properties of them. For physical properties, we can say that alkanes exist in three physical states, which are gaseous state, liquid state, solid state. In gaseous states, they are characterized by the presence of 1 or 2 or 3 or 4 carbon atoms. So the gaseous alkane, the number of carbons which are found ranges from 1 to 4. For example, methane, ethane, propane, butane. Liquid alkanes, the number of carbon increases from 5 to 17. For example, gasoline, اللي هو البنزين بتاع العربيات, kerosene. Solid alkanes, the number of carbon exceeds 17 carbon, like paraffin wax and grease. So the physical state again for alkanes, they are found in three states: gaseous state, liquid state, solid state. The gaseous state starts or the number of carbon 1 to 4. The liquid state from 5 to 17, more than 17, they are in solid states. Melting point. You have to know, as the number of carbon atom increased, as the number of carbon atom in unbranched alkanes increased, consequently there is increase in molar mass. And when molar mass increases, the melting and boiling point increase. Again, we can say that increasing the melting point or the boiling point is related to the number of carbon atoms which are found in the compound. An example, methane gas is a natural gas. In the natural gas is used as a fuel in houses. The mixture of propane and butane gases after liquefying is filled in cylinders known as gas cylinders, and it is used as a fuel. We can say that these cylinders in cold countries differ from the components of the cylinders in hot countries. Look at this. The gas cylinders in cold countries or cold regions contain higher ratio of propane, while the warm regions, they contain higher ratio of butane. Why? Because propane gas is more volatile with lower boiling point than butane gas. يبقى تاني في الكولد countries عايزة حاجة تتبخر بسرعة، فيبقى نسبة مين أعلى؟ in cold countries نحط بروبين أكتر، في الهot countries بنحط بيوتين. طب ليه بنحط بروبين أكتر في الكولد countries؟ Because propane gas is more volatile. Volatile means evaporate easily and means that it has lower boiling point than butane gas. Small hint, gasoline and kerosene, as we said before, can be used as a fuel. Liquid alkanes as gasoline and kerosene can be used as a source of fuel or as a fuel. Okay. Any organic compound can dissolve in polar solvents, but dissolve in non-polar solvents. So they can't dissolve in water, but dissolve in carbon tetrachloride or any non-polar solvent or organic solvent. Here we found that paraffin is an example of alkanes which are found float on the surface of water. It can't mix with water, it can dissolve in water. When I ask you, metals like iron are covered with heavy alkanes like these to protect them from rusting and corrosion. عشان هم مش بيدوبوا في المية فبنعمل بيهم ايه؟ الميتالز بنشحم الميتال يعني او بنحميه من الراست او الكروجن. يبقى تاني metals like iron are covered by heavy alkanes like grease to protect them from rusting or corrosion, where alkanes are nonpolar, water insoluble substance. If I ask you, write the structural formula of each of the following compounds, then arrange them ascendingly according to their boiling points with explanation. We have normal hexane, normal pentane, ethane type. Normal hexane means we have 6 carbon. So the carbon must be joined together. Then you know that the carbon must be surrounded by four bonds. So the other bonds will be saturated by hydrogen. This is normal hexane. Its formula C6H14. Its molar mass, the number of carbon 6 times 12, the atomic mass of carbon atom, so its molar mass is 86. Normal pentane, it contains, pentane means we have 5 carbon atoms, so if we get the molar mass, it will be 72. Ethane, it has 2 carbon atoms, so the molar mass equals 30. When we compare 3 compounds, we found that which one has lower boiling point? As the number of carbon atoms increase, the boiling point increase, and the melting point increase. So the lower melting point and boiling point is for ethane, then normal pentane, then hexane. So this compound will be arranged ascendingly according to the boiling point as the following: ethane, then pentane, then hexane. As the boiling point increases by increasing the molar mass of unbranched alkanes. Chemical properties of alkanes. Alkanes are relatively chemically inactive. Why? Because the carbon atoms are bound with single strong sigma bond, and sigma bond is difficult to be broken except under certain conditions. So the reactivity compared to other types of aliphatic hydrocarbon is lower. For chemical reaction, we will take burning reaction, thermal catalytic cracking process, and reaction with halogens. First, burning or combustion reaction with alkanes. We can say once any hydrocarbon like alkane burns completely, it produces 2 substances, carbon dioxide and water vapor, through an exothermic reaction. For example, when we have methane, CH4, and burn it in oxygen, what will happen? The carbon takes oxygen, changing into carbon dioxide. The hydrogen takes oxygen, changing into water vapor, and a lot amount of energy will be produced. So the reaction is exothermic. So you can say that if any hydrocarbon like alkene burns completely, it produces 2 substances, carbon dioxide and water vapor, through an exothermic reaction. We can say that methane can be used as a fuel. Why? Because it burns completely in high exothermic reaction, producing carbon dioxide and water vapor. If I ask you, calculate the volume of carbon dioxide that STP evolved on complete burning of 1 mole of each of the following: propane gas, butane gas. We can say this is C3H8 plus 5O2. It will give 3 carbon dioxide and 4 H2O. Here we have 1 mole of butane. It gives 3 moles of carbon dioxide. He asked me calculate the volume of carbon dioxide at STP evolved on complete burning of 1 mole of propane. So 1 mole of propane gives 3 moles of carbon dioxide. To calculate the volume equal the number of moles times 22.4. So the volume of carbon dioxide evolved equals 3 times 22.4 equals 67.2 liters. Okay. Second one, C4H10. This is butane. In this equation, after balancing it, we have 2 moles. Each 2 moles gives 8 mole of carbon dioxide. You want 1 mole. So the 1 mole gives what? By cross multiplication, we can say 1 times 8 divided 2, we get 4 moles. Well, 1 mole of butane gives 4 mole of carbon dioxide. When we get the volume of carbon dioxide, we take the volume times 22.4. It will be 89.6 liters. The second, thermal catalytic cracking process. What's meant by thermal catalytic cracking process? Catalytic cracking means the change of long chain hydrocarbon and short chain hydrocarbon through heating in presence of catalyst. So it is called thermal, means heating, catalytic, the presence of catalyst, cracking, the change of long chain in short chain. Thermal catalytic cracking process is carried out during the refining of petroleum ion to convert heavy long chain hydrocarbon or petroleum products. These heavy long chain products, less used, we change them into lighter and smaller molecules, which can be used easily or more used. This process is carried out by heating the heavy petroleum products under high pressure and temperature in presence of catalyst to produce what? 2 kinds of products. Number 1, alkanes, short chain alkane and short chain alkenes. Short chain alkanes are used as for a car fuel like gasoline, to fulfill the permanent world needs. يعني هما بيحاولوا يحولوا اللونج تشين هيدروكربون لشورت تشين زي الجازولين عشان في احتياج ليها، لان ده هو البنزين بتاع العربيات وكده، فبيبقى ايه بيحولوها من باي الطريقه اللي قلناها اللي هي ثيرمال كاتاليتيك كراكنج. نتيجه الثيرمال كاتاليتيك كراكنج بيطلع لي حاجتين، short chain alkane like gasoline which can be used to fulfill the permanent world needs. The second one is short chain alkenes like ethane and propene, which are used in many chemical industries like manufacture of polymers. Polymers دي زي البلاستيكس وكده يعني. Thermal catalytic cracking of octane compound. Octane means it has 8 carbon atoms. Octane compound is converted by thermal catalytic cracking into butane. And butene. Again, octane compound is converted by thermal catalytic cracking into butane and butene. So catalytic cracking means heating in presence of pressure and catalyst. They give ane and ene, alkane, which is called butane, and alkene, which is called butene. In the thermal catalytic cracking reaction, which is represented by the following equation C10H22, we get 2 types, alkane and alkenes. Look at the first, C6H14. If we try to get the general formula C6H CnH2n plus 2 يبقى هنعمل ايه؟ يبقى C6H2n يبقى 2 times 6 يبقى 12 plus 2 14 يبقى ده الان، يبقى ده الالكين. So 2y يعني ده هيبقى الالكين. Deduce the molecular formula of the product Y to which type of hydrocarbon does it belongs. طبعا هطلع ده الكين. هنا ده 6 يبقى ده هيطلع كام؟ C كام؟ بس هو مديني 2y. نفكر بقى. هيطلع ألكين بس هعمل times 2. اوكي. With halogens. Halogens means chlorine, fluorine, bromine, and iodine. This reaction takes place in presence of UV of sunlight, ultraviolet of sunlight. Alkanes such as methane react with halogens like chlorine gas by heating to 400 degrees or by presence in the by heating to 400 degrees Celsius, and this takes place in the presence of ultraviolet rays in series of substitution reaction. The product depends on the proportion of each alkane and the halogen in the reaction mixture. And again, reaction with halogens. It is called halogenation. Halogenation means what? The reaction with halogens like chlorine, fluorine, bromine, and iodine. If we look at CH4 with Cl2, what will happen? The bond between Cl will be broken by the effect of UV. Then one of the the 4 H's of the methane will combine with Cl, giving HCl. And the other Cl will be joined to the CH3. So we get methyl chloride or chloromethane. This is the first compound, and the HCl. If we take this compound and react to undergo a chemical reaction with chlorine gas, second steps, what will happen? It will add another chlorine and remove one H. So we get CH2, Cl2. The H will be removed, react with Cl, giving another HCl. This is called dichloromethane. The third step, if we add another chlorine, what will happen? This compound, dichloromethane, will add another Cl, and one of the H's go with the other Cl. We get CH, Cl3, and the HCl. CHCl3 is called trichloromethane or chloroform, which is used as anesthetic substance, مادة مخدرة بس كانت ليها dangerous effect يعني هنقولها بعدين. The last step or the fourth step, if we add Cl2, it will give the last H will be removed with Cl, giving HCl, and another Cl will be added, so we get CCl4, carbon tetrachloride, and HCl. This is called substitution reaction or halogenation in presence of sunlight or in the presence of UV. You will notice that we get 4 molecules of HCl, and the reaction takes place step by step according to what? The proportion of each of alkane and halogen in the mixture. The previous substitution reaction can be written as follows. CH4 plus Cl2 in presence of UV, it will give chloromethane or methyl chloride. When we get methyl chloride and put chlorine gas for another time, we get dichloromethane or methylene dichloride. The third step, methylene dichloride or dichloromethane with chlorine, it gives trichloromethane, which is called chloroform. The last step, trichloromethane with chlorine gives tetrachloromethane or carbon tetrachloride. Halogenation of alkanes cannot take place in darkness due to absence of ultraviolet rays, which are required to break the bond between C and H. What's the number of moles of HCl produced from the reaction of 1 mole of methane with an excess chlorine gas in presence of ultraviolet rays? We can say that 4 moles of HCl are produced because each methane molecule contains 4 hydrogen atoms, which are replaced by chlorine atoms in a series of 4 reactions. Halogenated alkanes derivatives. We have many derivatives of alkanes. First, chloroform. Chloroform, its chemical name trichloromethane. Its formula, structural formula, CCl3, CHCl3. It is characterized by, it can be used as anesthetic substance in surgical operations, but its usage is stopped now. Why? As its inaccurate estimation of its dose required for each patient, which may cause death. يبقى ده ليه precautions. البريكوشنز بتاعته لازم احدد الكميه اللي هتتاخد والا يسبب الوفاه. فدلوقتي منعوا خالص استخدامه. يبقى ده ليه certain precautions used as anesthetic. استبدلوه بحاجه ثانيه هنشوفها دلوقتي اللي هو قدامنا ده اسمه ايه؟ هالوثان. هالوثان. Its chemical name 2-bromo 2-chloro 1,1,1 trifluoroethane. Again, 2-bromo 2-chloro 1,1,1 trifluoroethane or halothane. هالوثين ممكن يجي لنا في الامتحان نكتب الستراكشرال فورمولا بتاعته او يجي لنا وهو يقول لي نكتب النومنكليتشر بتاعته او التسميه بتاعته. طيب ده بيستخدم في ايه؟ Used as anesthetic but it is safe. The other derivatives is 1,1,1 trichloroethane. 1,1,1 trichloroethane used in dry clean processes. Halogenated alkanes derivatives which are known as ferrions. Like what? Carbon tetrafluoride or tetrafluoromethane. Carbon tetrafluoride or tetrafluoromethane can be used in fridges as a cooling agent, in conditioners, air conditioners, and also as a rushing substance in liquids and perfumes. بيحطوه كمادة بتدفع البارفان لما نعمل ضغط على الإزازة يعني. اوكي؟ يبقى تاني tetrafluoromethane or carbon tetrafluoride. These derivatives can be used in fridges or air conditioners as a cooling agent, and can be used also as a rushing material for liquids and perfumes. Also can be used as a cleaner for electronic sets. Another example is difluoromethane. Difluoromethane. زي الأولاني carbon tetrafluoride or trifluoromethane. This is the most famous ferrion and also can be used in fridges and air conditioners or rushing material for liquids in perfumes or a cleaner for electrical sets. What are the advantages of ferrions? We use ferrions because they are cheap, easy to be liquefied, non-poisonous, no corrosive effect for metals, but their disadvantage is horrible. Why? They cause decay of ozone layer, which protects Earth from harmful effect of ultraviolet rays. So ferrion can be considered as double-edged weapon. Used so, there is an international agreement to prevent the usage of ferrions at 2020 Economic importance of alkanes. Alkanes play a very important role as fuel and also raw materials for preparation of many other organic substances such as obtaining the finely divided carbon or black carbon from methane. How? We take methane and heat it in absence of air in deep pools in Earth. Till we reach 1000 degrees Celsius, it will be separated into hydrogen and carbon. This carbon is called black carbon. Black carbon powder can be used in many things, in car tires, black ink, paintings, and polishes. So, the first economic importance of alkane, getting black carbon. And this takes place how? By heating methane in absence of air. This is called destructive distillation. Destructive heating. On heating methane in absence of air to 1000 degrees, the black carbon will be formed and can be used, as we said, for car tires, black ink, paintings, and also for polishes. Alkanes can be used to get water gas. How we get water gas? Water gas is formed by heating methane gas with water vapor in presence of catalysts. We take methane, then we heat it with water at 725 degrees Celsius in presence of catalyst. It will be changed into carbon monoxide and hydrogen. This mixture is called water gas. Water gas is very important, and we take it before. It can be used as a reducing agent in Medrix furnace. Used as a reducing agent in Medrix furnace and can be used as a fuel. We finished the explanation of alkanes. Till we meet again. Thank you.